Hello, everyone. Welcome to the webinar. Sorry, I started shifting slides there before we started the webinar itself. So um, just a couple of points. First of all, uh, everybody be muted throughout the webinar to control background noise, but we encourage you to ask questions at the end of the webinar. We'll open it up for everybody. And there's also an option to go through and type in a question throughout the webinar. We would encourage you to do that so that we can capture those at the end and make sure that we answer your questions. So I appreciate your patience as we got started there. We had a little bit of technical difficulty getting the audio going, but let's go ahead and get started with the rest of the presentation here. So we want to talk about the precision around your paper machines. Your paper machines are precision equipment. They were originally designed and originally built to be precision equipment. It's critical for the product that you're making, regardless if it's tissue, all the way up to the heaviest board grades. Your sheet profiles, your sheet machine direction variability, the ability to remove water from the forming section through the press section and all the way down the machine is it relies on the precision fit of your paper machine. And obviously your rolls play a large part in that. All the rotating equipment in your paper mill does, but on the paper machine itself, the rolls are a critical piece of that. On top of that, the majority of the paper machines out there are platforms that are now running beyond what they were originally designed to do. Changing market conditions have required higher production at lower basis weights, higher strengths, tighter quality requirements from your customers with respect to smoothness, caliper, moisture, basis weight, other surface properties for print, all at higher speeds and higher efficiencies than many of the machines were originally designed to do. So honestly, tons of production on your paper machine depends on tens of thousands of an inch. So critical roll maintenance, critical roll servicing is a large part of the proper runnability and the proper maintenance of a paper machine. Here on the left-hand side, you can see a typical roll, quite honestly. The scale is relatively small, but it's critical to start rolls as close to perfectly round as possible when they go into your machine after they've been serviced. Not only does it affect those parameters that we were talking about earlier with respect to your cross direction profile, your machine direction variability, all your quality parameters, but it also affects the length of the time that that roll can run while maintaining the things that you need it to maintain on your paper machine. So getting as close to perfectly round as possible is critical. It drives decreased variability, which obviously drives the economics of your paper machine. Every section of the paper machine has its own unique needs to maintain the kind of quality and the kind of production that you're looking for. In a forming section, it's improved machine direction and cross direction basis weight and moisture variability, primarily high frequency. That's very difficult to detect on the machine, even with the scanning platforms that are out there now, and particularly tough to detect in the paper testing lab as you go through that. So improved weight and moisture control. It's fewer issues that are carried down the paper machine into the press section, into the dryer section, through the calendar section, onto the reel. If you have size press or coders on the machine as well, the more you can do on the forming section to reduce variability, the better off it is downstream. Suction roll performance is terribly critical on a paper machine. Efficient water removal, the energy reduction, and those rolls are expensive to take in and out. So you want to run them as long as you possibly can. Cooch vacuum, as an example, is critical to ensure that the sheet is strong enough to transfer into the press section properly and give you the kind of results that you need from the press section on. Speaking of press sections, breaker stacks, size presses, on-machine coaters are all terribly critical with respect to roll shape, to roll roundness. Excuse me, the reduction and elimination of wet streaks is something that, in my experience, every paper machine goes through at one point in time. Energy reduction on those suction rolls, as we mentioned, and of course, longer run life on your rolls. In addition, in coaters, it's consistent coat weight across the web. In size presses, it's consistent application of starch or whatever product you're putting through your size press. And then, of course, calendar roll performance is really critical. We'll talk in a little bit about how the calendar stack is the most important piece of the paper machine with respect to reducing variability. But better reel building leads to better performance downstream, not only through your winder, but also with your customer. Improved strength variation. Quite often we don't think of the calendar stack in relation to strength, but it is critical, as we'll show. Fewer sheet breaks at the calendar and reel, and again, longer run life of those rolls. Every time you've got to pull a roll out of a paper machine, it's a maintenance effort that you all know, and the more you can minimize that, the more you increase the safety around your outages, the more you free up resources to do other critical things on your paper machine. So we would ask you not to discount the longer run life of rolls as you start those rolls more closely to perfectly round when they go into your paper machine. So again, the whole idea behind proper roll service and world-class roll service and grinding is to reduce variability and cost from wet end all the way down through your reel, and to drive profitability. Just to recap, in the forming section, it's cross-directional and machine directional basis weight variability. Coming off the couch roll and into the press section, it's moisture variability, energy savings through proper suction roll maintenance, reduction in wet end breaks. There are many breaks that are hard to identify. How often is that coming from some kind of variability within a suction roll, or some kind of machine direction variability off of the roundness of a roll, or some kind of shape variability off the cross direction profile of a roll? In a dryer section, obviously steam demand reduction is huge. You know, the 4-to-1 ratio that plays out between what you can get out in a press section versus what you have to do in a dryer section generates large economics on a paper machine. And then as we get down to the calendar, it's obviously caliper variation, which leads to strength variation, gloss and smoothness variation, and then, as we had mentioned earlier, much improved variability for the end user. And the end user starts with the winder in a paper machine, and then goes on, obviously, to your customers and how they're converting it, how they're printing it. So the forming section, it's a really important area that impacts formation. Obviously, cross direction and machine direction profile. It drives sheet strength because you're forming the sheet, obviously, in this spot. So the breast roll, the forming rolls, and gap formers are all very, very critical. And we watch those very closely with our partners in the paper industry to make sure that the shape and the roundness of those breast rolls and forming rolls is adding as much to your process as possible to reduce variability as you begin to form the sheet. Obviously, in the press section, press roll performance, improved moisture variation and solids entering the dryer section. It starts at the couch through suction pickup and transfer rolls, suction rolls in the press, blind drilled rolls in the press, making sure there's proper crowns that are in your roll shape properly, making sure that roundness is there. Even with softer cover press rolls, we've seen a number of occasions where crown matching is critical, and we'll see that here on this slide, this is an actual before grind and after grind profile. This is with a new cover. And if roll grinders are not careful, without getting into the technical aspects of how roll grinders work, crowns can get off center. And we've actually seen evidence of that in smart covers that are measuring the pressure. We've seen evidence of that a number of times in basis weight, they're not basis weight, I'm sorry, but moisture variability all the way down the remainder of the machine. So even with press rolls, even with soft covered press rolls, it's critical that the grind is right. It's critical that the crown is right, that the roundness is right to get the maximum performance out of your press section. This is generally how it manifests itself. You know, there's a moisture streak as represented on the left-hand side, and the entire machine is being controlled to that moisture streak. As a matter of fact, in the paper industry, we're notorious for hanging other equipment on the machine from the press section down, actually starting in the forming section with steam boxes, but from there down with infrared dryers, with compensating controls on calendar stacks that many times are trying to cover up what is caused by improper roll grinds down your machine that are causing moisture variation. So with a streak like that, in many cases, the machine is slowed down to control that streak. With proper roll service, we've seen many examples where we're able to do what's on the right-hand side there and help maintain a much better moisture profile, and therefore, instead of having to run a lower overall moisture target, you're able to shift that target up, and in many cases, speed up the paper machine to shift that moisture target up, and thus driving economics. And this is a real simple calculator that we've used with customers. It shows, and this is a actual case where the average real moisture prior to doing precision roll service and roll grinding work in a press section averaged about 6.2%. Production rate averaged about 50.5 tons per hour. By minimizing the variability of the moisture in the press section, they were able to increase the overall moisture, sell more water, but more importantly, speed the machine up to do that. So, you know, these are some relatively conservative numbers, and we've got a number of calculators like this for each roll position in a paper machine that we're happy to sit down with you and go through and leave with you so that you can plug your own numbers into them. But this was a savings of about $1 million a year for this customer due to the fact that they didn't have to compensate for a moisture streak. And then we get down the machine to the calendar, and that, in backing up to that, that also plays out in size presses and coders on paper machines. At the calendar, there was a research study done a number of years ago by FP Innovations up in Canada, and this was an independent study that concluded that the section of the paper machine most responsible for machine direction and cross direction variability is the calendar. We think quite often most of it happens prior to the calendar, but the calendar is that critical. The picture on the left-hand side is actually a number of nip impression sheets that were run in the machine direction through a calendar. So the bars you see there are the barring in the calendar rolls, which obviously are inducing machine direction variability. And again, if crowns aren't right, if hydraulically controlled variable crown rolls aren't right, your cross-direction profile suffers as well. And it leads to high cull losses. It leads to downgraded product, poor winder performance that sometimes we don't often think about, and then poor quality to the end-use customer that we had mentioned earlier. On the right-hand side is what's really fascinating. Caliper variation through this study of as low as 5 to 10 micrometers was shown to cause strength variation of up to 20%. So those mystery sheet breaks around the dry end, the winder breaks that aren't attributable to, you know, a cracked edge or something else on your paper machine. how often is that coming from a calendar stack that isn't maintained the right way with proper roll grinds and service on the variable crown rolls. We mentioned it a number of times throughout the webinar, but the added bonus is as you start closer to perfectly round, your rolls run longer. And 2.5 times longer has been proven out with a number of our partners in the paper industry. This is an example of calendar roll work where the OEM specification for roundness on calendar rolls is 2/10,000ths of an inch. Quite often they come back from grinders at 4 times that much or more, 8/10,000ths or 1,000th. The wear on a roll is relative to its roundness, right? So as it loses roundness, the wear increases, and it's not a linear relationship. You can see on this graph, it's almost exponential. So it takes about a year of running a calendar stack roll that started with a tolerance of 2/10,000ths to get to where many other roll grinders start that roll at 8/10,000ths or 1,000th. So again, we're willing to come in and sit down with you and show you the examples of this and work with you to really extend the run life of calendar rolls. And this plays into effect on any roll in your paper machine. So again, it's lower maintenance costs because you're changing out calendar rolls every 15 months as opposed to every 6 months. Increased manpower for scheduled shutdowns. You're able to shift that manpower. You're able to free up crane time. Longer term product quality. You maintain the kind of profiles that you're looking for and the kind of production and quality that you're looking for over a longer period of time. And we'll end with this. We've talked about a number of issues throughout the paper machine that really are critical with respect to roll grinding and roll servicing. Precision Roll Grinders is committed to showing you that value statistically. It's our promise to provide value for what you're going to spend with us to get precision roll grinding and precision roll services. So it starts, the little graphic on the right-hand side, it starts with data. We take a 6 Sigma rigor approach to that data. We have an application engineering group that works with your process engineers or whomever is designated in your facility, in your paper mill, to work with us to gather that data so that we have statistically sound representation of what has happened before and after. We actually work with you to drive that to a predictable or predictive, I should say, equation where you know what you can expect each time that you work with precision roll grinders on your roll service needs. And ultimately it drives to better economics for you. We're committed to showing you above and beyond value for it's not really a cost of doing business with us, it's the investment of doing business with precision roll grinders. So again, even in this virtual world, we're working with customers to send packets out to gather samples if we have to do physical samples. We're working with customers to pull data off of plant information systems, distributed control systems to analyze. We work with our partners to do joint designs of experiment that outline variability reduction that is specific to your needs and specific to your paper machine. And then we work from that. So we would encourage you to reach out to your local account manager, reach out to any of our facilities. We've got our facilities listed here. Encourage you to get on the website where you can see these webinars again and go through them and share them with others and just kind of review how critical it is throughout each phase of the paper machine to maintain the highest quality roll grinds and mechanical work throughout your machine. So we appreciate your time. This webinar will be available on our website. we would encourage you to share it with others and to reach out to us with any questions you might have. So at this point, I will work on unmuting everybody if there are any questions, or you can type in questions as well. Okay, if you have a question, feel free to unmute your microphone and ask it, or you can type one in. One of the questions that we get is, how long does one of these studies take? Well, it depends quite a lot on the role position that we're talking about. There are press roles that generally run for a year. We like to work with you on improving your quality and extending that role life. So sometimes they take quite some time. Calendar roles are changed out anywhere from 6 months to a year or a year and a half. But one thing that we can do, even if you have not utilized our services, is gather that baseline data ahead of time and then put together a design of experiment. And we're flexible with customers on commercial aspects of doing that, so that we mitigate the risk for our partners to utilize our services and document that value over time. So it's dependent upon what we're trying to accomplish with our partners, but again, we would encourage you to reach out and talk to your local account manager, reach out to one of our facilities as listed here, take a look at our website and see what's there. Okay, well, again, we thank you for your time. And again, this will be available on our website. It's a series of webinars that we're doing, so we would encourage you to get on the website and check out what the next webinar is going to be. If you're interested in a one-on-one webinar with your facility or just you individually, then we're happy to do that as well. So again, thank you for your time, and we look forward to working with you soon. Goodbye.